you have identified your topic, your research gap. You can write research questions, objectives, formulate hypothesis, literature review, the role of ICT. This one we're continuing. And now this role of ICT is now AI really mostly. We're going to see methodology, research design. You've covered sampling techniques, measuring and scale techniques, data collection methods, surveys and planning, cover the quantitative and qualitative ways of collecting data, pre-testing. Now, when you're doing your questionnaire, let me just mention something about the questionnaire. Not everyone needs a questionnaire. You only need a questionnaire if you're going to, of course, have participants or patients that you're going to ask questions about. So when you're writing a questionnaire, it of course has to do with your topic. Now, when we say you pre-test your questionnaire, it means once you write your questionnaire, of course, you've given your supervisor, they've looked through. You do not decide that you have your N is 300 participants and you go ahead and print 300 questionnaires. You need to test your questionnaire. Okay. The purpose of testing your questionnaire is number one, to avoid wasting time so that you can stay within your work plan. And number two, to make sure your questionnaire, the most important thing is actually to make sure your questionnaire is to the topic that you are asking questions about. Your objectives are within the questionnaire. Number three, you want to save money. You can imagine printing 300 questionnaires only to discover in questionnaire number 5 that there are questions you left out, or that there are questions that don't make they're not relevant to your study or to your participants, or you should have refined your questionnaire a bit more. This is what we're calling pre-testing of the questionnaire. So you have to print a few questionnaires. First of all, you can ask your supervisor. Next, you can test with a small population of people, about 5. Yeah. So that you're able, so only print the 5. Test, check what kind of information you're getting from your participants before you go ahead and print the final questionnaires, 300 of them, and waste all your time and money there. So you want to refine your questionnaire when you're pre-testing your questionnaire. Ethical consideration we have covered, budget and resources I've told you about, work plan we have talked about, and now I want us to start a topic which is possibly you've done before, of statistics. So I usually cover this in a hurry because you have covered statistics before. Am I correct? Faith, have you covered statistics before?
Yes.
Okay, so if you've covered statistics before, I will just rush through. And what do we rush through? Look for PowerPoints. If there are none, we start some. I'm trying to look for PowerPoints. There are none, so I'll start. I can't find them. To save time, allow me to start a new PowerPoint and label it statistics. So let's put you on the screen. Then we see what we can talk about. So for those of you, I hope you know how to make PowerPoints. Of course, there are also some AI tools that you can now use to make statistics, to make PowerPoints. So I hope you can see my slides. Can you see my slides?
Yes,
yeah, so I want, yes. Yeah, okay, I just want to label my slides, statistics, and then those who don't know how to make slides, just this is the manual way of doing it, statistics. Yeah, so I have now put many slides. This is how you'll make your slides. This is also a lesson. When you're writing your, here you'd put your title in the first slide, maybe. For paper, someone has written economic burden of unsafe abortion on healthcare system. That is a topic that was given by one of your, I just want to see, one of your classmates. A good topic. Okay, so how will they do the statistics? So exactly what is statistics is the first thing. So you said you've done statistics. What is statistics? Faith, who has told us they have done statistics. What is statistics? Anyone? What is statistics? Yes?
It's how you collect, how you analyze, how you interpret and present data.
That is correct. So before you collect data, you have to understand the problem. Like I've told you, the person here has talked about the economic impact of, where is that paper? Of abortion in the healthcare system, and they give us a long story here. So during the ward rounds, this person noticed the logs in the gynecology ward logs more than half of the causes of unsafe abortion complications. So, okay. So you have to understand what problem are you trying to collect data. So this person is attempting to collect the economic burden of unsafe abortion in Kenya. Okay, so you have to understand the problem so that you're able to know what it is that you want to solve. So to understand the problem, first of all, you need to define the problem. And to define the problem. And once you define the problem, you know who are your participants. Yeah, you have to know who your participants are. And this is going to help you to determine what kind of data you're going to collect. Yeah, like here, I don't know if this person is going to go to the files or going to go and find the patient at the bedside and ask exactly what is going on. And then once you identify who you're collecting, who you want to target, you also want to know how to collect the data. You want to know how you're going to collect the data. And then you want to know how to interpret the data so that it makes sense in whatever you want to, whichever problem you want to present. And once you can interpret the data, you're able to analyze the data. So we're assuming this person is going to tell us, the abortions are 3,000 per 5,000 births, who knows? And so these are the issues. And then once you know how you're going to analyze the data, we hope that you can be able to present your data, to analyze data, and then hopefully present your data. So in statistics, in your paper, at your level, this is the kind of information that we would like to know in your study. Okay. Then from that kind of information, you're then able to answer questions on your objectives, your aims of the study. Okay. So before you decide which method to use, you have to undergo this problem. You understand whatever you want, you define whatever it is you're trying to do, you know where you're collecting the data from, you decide how you'll collect the data, which methods, which kind of data you're collecting, and then finally you're able to interpret and then analyze and then present your data in a way that is understandable to the people who you are trying to send. So the first thing is, we assume that you have been able to understand your problem. How? From your title from your going to the field a bit, talking to your supervisor, etc. Then you decide, oh, so what kind of data am I going to collect? What kind of data am I going to collect? So types of data. What types of data are there? There are two types of data. Number one, we have categorical. We have categorical data. And what is categorical data? It is data that can be identified based on names or labels. So it can be ID'd based on labels. This is categorical data. Yeah. For example, what? For example, e.g., it is categorical. You are either married, or you are single. You're not in the middle. You're either married or single. Yeah. Your blood group is either A or B or AB or O. Okay. So we can give a label to it. That is categorical data. Another type of data you can see you'll collect is numerical data. So what is numerical data? Numerical data, here, we can divide it into two. Yeah. The fact that it is numerical means it is numbers. It is numbers. So it is numerical. How do we divide it? We can say it is discrete data. We say it is discrete data. And what do we, or B, we say it is it's either discrete or it is continuous data. So when we say it is discrete data, what do we mean? It means it takes only, so say can take or can be assigned discrete values. It takes discrete values. It can take discrete values, can take discrete values or labels. What do we mean it can take discrete values? We can say that how many students attended the class today? Today there are 40 students. So 40 students attended the class today. So e.g., we have 40 students attended today. Last week we had the last class we had maybe 44 last week. The week before we had 52, something like that. It is a discrete value. It's not 42 and a half, 36.2. It is a discrete value. It cannot be subdivided. Okay? It cannot be subdivided meaningfully. It is a discrete value. If it is continuous data, okay, if it is continuous data, this kind of continuous data can have numbers that may not be complete. So continuous data, number one, we say it can be calculated. It can be calculated. It has an infinite number of probable values. So we say infinite number of probable values. An infinite number of probable values. Okay. It represents measurements. These values, we say, you can't count these values like the students, but they can be measured. Okay. So can be, you can't count them. So we can say they can be measured. So we have an example of what is the age of the class participants today? So age, yeah, age, 23.4 years, 23 years and 4 months, 30 years and 2 months. Temperature, what is the temperature? Yeah, temperature. They can be measured, okay? Discrete are discrete values, yeah? And we said these ones, they contain infinite, yeah? Discrete values contain infinite number of possible values. Here we said infinite number of possible values. But here in continuous data is infinite number of probable values. So in discrete data, the values cannot be subdivided. You can count them. But in continuous data, the data can be calculated. The value can be counted but cannot be measured. So those are the two types of data. Categorical data, are you married, are you single, or are you Kikuyu, or are you Maasai? It's a label. Are you blood group A or blood group O, positive, something like that. Numerical values, they're numbers, discrete and continuous values. Okay, then we can also say, so I hope, had you done that in your statistics? So you'll collect data on two values, numerical values and discrete values, depending on the study you are doing. So had you done that type of value system? Yes or no, Faith?
Yes.
Yeah. So I hope you are able to define the types of data that are available. Okay. And then we can also say, remember, we also said that we can have different types of value, and we divided them last time. We can then divide our data into further 4 parts. And which 4 parts did we say last week we can divide our data into, or the week before? In brief, we said last week, or the week before, we covered, and I sent also the levels of data measurement. Which other levels of data measurement are there? We covered 4. And just now I've showed you the course outline, and I've talked about levels of data measurement that we have done. Or have we not done levels of data measurement? So our data can either be categorical or it can be numerical. Numerical data can be discrete data, or it can be continuous data. But we had also covered other levels of data measurement. And the reason we're doing this is because it's for you to determine how you'll know what kind of data you're analyzing. By knowing what kind of data you're analyzing, you're able to come up with hypotheses, you're able to test your hypothesis. We covered 4 levels of data measurement. Anyone? Did we cover nominal data, ordinal data, interval data, ratio data? Yes or no?
Yes, indeed.
So this is exactly why we need the cat. We're wasting time doing things and no man knows. So we said we can also have other ways of classifying our data. We said it was nominal, and I gave you the examples. We talked about it. Nominal data, we said it's used to label, it's one of the lowest forms of collecting data or labeling your data. Okay. We said it can be nominal, which is the other one we said. We said nominal. It is the most basic. Did we not say that? Yeah. It's used to label variables where there are no quantitative values. So nominal, your data can be a nominal. For example, gender, you're either male or you're female. We also talked about ordinal data. Yeah, this is statistics now. Ordinal data. And what did we say about ordinal data? We said ordinal data, it categorizes like nominal data, but there is a natural rank. For example, your grades can be excellent, they can be good, they can be average, they can be poor. Okay? Did we cover this or not? Huh? We talked about interval data. Huh? We said in interval data, we now start being numerical. So it is quantitative. We measure numbers. Yeah. But here we have an arbitrary zero. Yeah. There is no meaningful zero. For example, yeah. Just the temperature today is low. So we can have temperature beginning in places minus 40, somewhere in the Arctic. We can have the minus 30, 0, 12, like that. So here we have a 0, but the 0 is an arbitrary 0. It does not mean there is no temperature. There is no meaningful 0. There is no meaningful 0 point. Interval data. Have we covered this or not? Then we talked about ratio data. And what is this ratio data? We said it is ordered. It's a more sophisticated level of data. Here, we said we have a 0 point again. The 0 point is absolute. And then I send you reading material. No wonder you did not want the cat. So we have now divided our data into either categorical data or numerical data, okay? And our numerical data can either be interval data, it can also be ratio data. Our categorical data can be nominal or ordinal. Are we together? If we're not together, can we repeat whatever it is? Are we together?
Yes.
So I hope we're together. So in short, we're just saying that actually these statistics, it's just a branch of maths. It is a branch of numbers. It is a branch of maths that deals with how you will collect your data with collecting. It deals with collecting your data. It deals with analyzing your data. It deals with interpreting your data. I will interpret your data. It deals with how you will then present your data. I will present your data. It deals with collecting, analyzing, interpreting, presenting, and let's say, and organizing. So that is exactly what statistics is. So that your numbers will make sense, okay? For the purposes of fulfilling your research objectives. So that is what analysis statistics is. Now, once you have decided what kind of data you're going to collect, you have to then analyze your data. Yeah, you'll have to analyze your data. When you're analyzing your data, there are two methods of analyzing data. Okay, you can have your statistics can be, number one, descriptive. Statistics can be descriptive. And number two, your statistics can be inferential. So it can be descriptive or inferential. If your statistics are descriptive, what are you doing? If your statistics are descriptive, you are trying to descriptive, yeah. So you are trying to in descriptive analysis of data, it means that you are describing the data you collected and summarizing it based on something called central tendencies, okay, and measures of dispersion. So here we are saying that you are using, so you say that you're using measures of central tendencies, and then measures of dispersion. Now that you've done statistics, what are these? Faith, who told us, she's done it. You have done this unit. So in descriptive statistics, you're using measures of central tendencies and measures of dispersion. What does that mean? Anyone can help Faith in these hard times? Anyone? Let me pick from. Yes.
I remember measures of dispersion being like things like range and standard deviation and variance.
So she's correct. We do have the measures of, so in this, when you're describing your data based on descriptive statistics, you want to talk about the measures of central tendencies. Measures of central tendencies are things like mean, okay, median that you have done, mode, okay. Measures of dispersion include things like interquartile range, standard deviation, okay. Standard deviation can also be variance. She's told us about variance. Then, by the way, you can also add here and measures, put here as dispersion. We say that we want to talk about measures of central dispersion, comma, central tendencies, comma, and shape of data. Yes, shape of data. What do we mean by the shape of data? How are your graphs going to be shaped? Because is your result in terms of skewed data? Is it skewed to the left, skewed to the right? So skewedness, that is the shape of data. Or is it bell-shaped? Is it symmetrical? Is your data symmetrical? Is it having some kind of kurtosis? Okay. Is your data scattered? So the shape of the data. So like you said, you've covered it before. So when we're talking about the descriptive statistics, we are interested in how is the mean, the mode, the median. The mean meaning, what is the average? The median meaning, what is the 50th percentile? The mode meaning, what is the most frequent presentation of data? Yeah, what is the most, how often, which data is being presented the most? When we talk about dispersion, since you have done these topics, we're talking about what's the interquartile range, what is the range, what's the standard deviation, and such, other such issues. Okay, so I hope we're together. If we're not together, kindly stop me. So refer to your notes. I'm just reminding you exactly what you're going to talk about. Now, we are saying when you analyze your data, we also have inferential statistics. We also have inferential statistics. So what is inferential statistics? These types of statistics, it draws conclusion from the data. Okay, it draws conclusion. What does that mean? It draws conclusion. Sorry. Here, draws conclusion. You want to draw a conclusion. Conclusion from data, from the data that you have. So how do you want to draw a conclusion from the data? You want to compare, to test two groups. Then you'll have identified what we call a p-value. And then you will then draw the conclusion, is the data supporting your hypothesis or not? So descriptive data, it quantifies the characteristic of data. So descriptive data, this one, it quantifies. Like I've showed you, it deals with numbers. It quantifies, yeah, the data. It quantifies the characteristics of data. It quantifies the characteristic of data. Is it a mean? Which one is a median? Which one is most common? What is shape? What is the standard deviation? But inferential, it draws a conclusion it draws a conclusion from the data, yeah, about the population. Because you have sampled it draws the conclusion from data about a population. Because you see, you have sampled your data. You have got 3,000 students. You're not going to interview 3,000 students. You're probably going to interview, calculate, maybe you have 200 students. You're going to use those 200 students to then make a conclusion based about the 3,000 students. So in inferential statistics, you require statistics to select the sample and then to draw a conclusion on the population. And then you can also use it to identify differences between the two populations. Okay, so in descriptive statistics, we're dealing with measure of central tendencies, dispersion, and shape. So you are quantifying the characteristics of data. Okay, then once you quantify the characteristics of data, you talk about central tendencies, dispersion, and shape. Yeah, and then you describe the characteristics of a known sample or population. So here you describe characteristics. Describe characteristics of a sample or a population. Here in inferential, you're drawing a conclusion from data about a population, yeah? But this population, you're getting the information from a sample. So here we're using analysis tools. You select a sample. So analysis tools used on a sample. And once you do that, you can then test a hypothesis. You test a hypothesis, and then you can then make a conclusion. You can make an inference, hence the name inferential. You can use an inference about an unknown population. Why unknown? Because you picked a sample. So here, whereas in descriptive statistics, you are using, in descriptive statistics, you're using things like mean, mode, median, standard deviation, variance. Here, in inferential statistics, you are going to do t-tests. You're going to talk about t-tests, z-tests, regression, we call it linear regression. So it depends on your study, what it is you're trying to get, linear regression. So are you seeing the difference between? So you're going to test, you're going to have like a p-value in inferential statistics. You're going to have an alpha value. And then you conclude whether the study, your results are significant or they are not significant. Are we together? Can we have questions? So there are softwares that can do this for you. The problem is, how do you analyze your software? Okay, how do you analyze your software? So inferential statistics, we're saying you use analytical tools to draw an inference about a population from a sample data. Okay, from a sample data. Okay, but in descriptive statistics, you use descriptions to quantify the characteristics of data. Are we together? So inferential statistics, it will just draw conclusions from a sample about a population. Okay. Now there are two types of inferential statistics. I don't know if this is your level or not. I don't know. You just know there are two types of inferential statistics. We have what we call hypothesis testing, and then we have regression analysis. So I don't know how the course outline, I never go above that, but just for your information, there are two types of inferential statistics. You're either going to test a hypothesis or you're going to do regression analysis. So when you're choosing a sample, your sample should be representative of an entire population for you to be able to have an inference about the population. And that is why we talked about how do you do sample selection. We talked about different methods of sample selection. Can anyone remember that? Or it was too far away? We said how many methods of sampling are there? How many types of sampling do we have? Bruce nje.
Probability sampling.
And what is probability sampling?
It's sampling that just gives generalized results.
Yes, we said it uses random methods to select a sample from a population. It gives generalized results. Rita Migichi, give me the next type of sampling.
So we have stratified sampling.
No, he's told us probability sampling as
None.
the fact that one is probability, it's using random sampling. The other one is non-probability. So you can't fail that question. It's either probability or non-probability sampling. So non-probability means the sample is non-random. In probability, the sample is random. In non-probability, the sample is non-random. Okay? And why are the two methods different? In probability, yeah, we've been told by Bruce, it gives generalized results. But in non-probability, it needs richness of data. Okay? So while as probability sampling, yeah, wants to ensure that you have an unbiased sample which is representative, therefore, you use methods such as simple random sampling, every participant having an equal chance, or stratified sampling. We have male and female, or people from Nairobi County and others from Thika, I don't know, Kiambu County, and then you have subgroups, and then you pick from that subgroup, that is stratified sampling, or cluster sampling. Yeah, so there you have probability sampling. But in non-probability sampling, you're interested in richness of data, so it is more biased. So I will come directly to you and ask you about your condition, where you're from, purposive, it is judgment, or even convenience, because it's easier for me to come to you because you are in JKUAT, I will say that's convenient sampling. That is a non-probability sampling. So it's very difficult for me to say that kind of sampling that have come to JKUAT will represent all universities in Kenya. Or you can use snowballing. We said, for example, in sensitive populations, or very rare populations, they can refer you to each other. Okay? So we are saying that in inferential statistics, you need a sample that is chosen, that is representative of a population. So if you decide to do inferential statistics, and that's what you're saying, you see, in your head, you're already planning how you'll do your research. If you're going to collect inferential statistics, you need to have a sample that is representative. So you'll use non-probability sampling. Okay? Are we together? Now, in inferential statistics, you can then do things like, hypothesis testing, yeah, using this kind of test we're talking about, Z-scores and all that. You can then use, you can also use estimating parameters, for example, using standard deviations. You can do confidence intervals in inferential statistics, and there are methods of doing it, which I hope were covered in statistics, the unit statistics. Okay, now, have we so far reviewed your statistics class? If not, kindly say so that we can go through the unit again. Are we together or not?
We haven't reviewed it yet.
But Faith has just told me you have done this unit of statistics.
Yes, we've done the unit itself, yes.
But they did not cover this kind of topics.
Not to my remembrance.
Because the whole unit you covered what? Because this is basic statistics. What did you cover? Did you cover types of data?
Types of data mostly and the calculations.
And the calculations. So we'll briefly go through descriptive statistics. And I'm very sure you did it. Maybe you are forgetting descriptive statistics. And before we do hypothesis testing, new slide. Let me talk about descriptive statistics. So these descriptive statistics, we have already, or I have already given you the difference between descriptive statistics. We have said there are two types of methods of analyzing data. It is descriptive. Your analysis, you can use descriptive statistics. Yeah. You can use descriptive statistics. Or you can use inferential statistics. So there are two ways of analyzing your data, descriptive and inferential statistics. Okay. So descriptive statistics, we said it quantifies the characteristics of data. Okay. And then we have given the examples that you can cover: measures of central tendency, measures of shape, measures of dispersion. Okay, but inferential statistics, it uses other things like inferential tests. Okay, like t-tests. Okay, in descriptive statistics, it describes the sample. The mean of the sample is 5, the median was 2. But in inferential statistics, we use it to say that the sample is representative of a population. So it infers. Then we test a hypothesis. Okay, we test a hypothesis. So now in descriptive statistics is what I want us to go through quickly. It talks about numbers, it talks about numerical and graphical ways to describe data. So it is numerical and graphical ways to describe data. It's numerical and graphical ways to describe data. That's why we're calling it descriptive. It is describing. I hope we're together. So what are the measures we talk about? We talk about number 1, central tendency. When we talk about central tendency, is where is the center of data? Where is the data located? Where is the data located? For example, if we have how many people got 5 marks out of 10, someone else got 5, another one got 6, we have 7, we have 8, and we have 10. 1, 2, 3, 4, 5, 6, 7. So these are the marks of the cat out of 10. Okay. So when we talk about here the measure of central tendency, I can tell you about, let me go down. I can tell you about the mean. What is the mean of this data? The mean, it just means we add everything, yeah, and then we divide by the number. So we shall say 5 plus 5 plus 5 plus 6 plus 7 plus 8 plus 10 plus 7 plus 8. So what is the mean of this data? Plus 10. Who can tell us the mean? So we're going to divide this, we're going to add it and then divide it by the number of occurrences. Here our number of occurrences are 1, 2, there are 6. So who can tell us the mean? Anyone? Surely.
6.8.
It's 6.8, eh? 0.8. So how did we come for 6.8? So what is the total number? What is the total number? First.
41.
Yeah, 41. And then we divided by the number of occurrences, which are 6. And then our mean is 6.8, meaning this is the average of our data. So the class average for the mark was 6.8. So from this data here, we can also determine the median. So what is the median? What is the median here? So the median is the 50th percentile of data. It is the exact center point of the data. Now here we have six marks. So our median would be the 6 plus 7, yes, 13 divided by 2. So our data would be 6.5. Our median would be 6.5. Are we together? So you have to order the data in median. You order the data, and then you split the number into 2 equal parts, and then you find the number. So it is the best way to find the center of the data. It is a measure of central tendency. Now, in mean, here in the mean, the problem with the mean is that it is influenced by outliers. For example, there's someone who got 10, there's someone who had 5. So our average is 6.8. So this is the 6.8 is being influenced by our outlier. The one who got 10 out of 10, and the one who got 5 is influencing the center of the data. But here our median, we have said, is going to be 6.5. Are we together? Why it's 6.5?
Yes.
Yeah, it's 6.5. Why is it 6.5? All I have done is taken the 6 plus 7, because I have taken, I've ordered my data. First of all, you have to order it. If it was not in order, I would have to order it. So it is in order 5, 6, 7, 8, and then I've divided it into 2. Now, suppose I had another figure here, like someone who got 6.5. Then, in this case, our median would be 6.5, because 5, 6 is 1/2, and then 7, 8, 10 is the other half. So our median is 6.5. So the thing with median, it's not, it actually gives you the best center of the data. Why? Because it's not influenced by outliers. Can you see the 6.5 here is not influenced by any outlier, by the 10 or by the 5? Are we together? So that is a way of central tendency. Now, if I ask you the mode here, if I ask you the mode, what is the mode? It's the most frequently occurring data. Are we correct? Most frequently occurring data. Again, always order your data. Okay. What is the mode here?
It is 5.
It is 5. It is the most frequently occurring data. So these are what we are calling measures of central tendency. Okay. It describes the location of data and concentrates where the data is located. So we have 3 measures of central tendency: mean, mode, and median. Okay. And I've shown you how you get it. So everyone, that is clear. Even you use a software, you still have to know what the description is. If you use AI doesn't have to be correct. You will just make mistakes. You can use Excel, you still have to explain what it is. So these are, the first thing is, descriptive statistics is our central tendency measures. I hope we're together. So another way to describe data for descriptive statistics is what we are calling dispersion of data. Dispersion of data. Remember we said descriptive statistics talks about measures of central tendency, measures of dispersion, measures of shape. What is measures of dispersion of data? And how all this coming in, by the way, when you're doing your research? Suppose you are collecting your data here. Here I've seen someone who wants to do, I don't know, assessment of anti-venom availability, street treatment outcomes, gender differences in snake bite. Are you hearing to this title? This title is like a book. Assessment of anti-venom availability, comma, treatment outcome and gender differences in snake bite and envenomination caused by Gabon viper, in brackets Bitis gabonica, in the semi-arid area of Turkana, Tharaka Nithi and Meru counties, Kenya. The title itself is a book. So we'd expect him to tell us, so once he sorts out the title a bit, in these Tharaka Nithi and Meru counties, what was the average availability? So maybe in Tharaka Nithi, we should be able to conclude that there may be the availability of the antivenom was more in Tharaka Nithi than in Meru, based on just these descriptive statistics. There were 3,000 more vials in Tharaka Nithi than there were in Meru, because you're able to just describe your data first before even you start talking deep things. You're describing your statistics. Are we together? I hope we're together, because this is how you will describe your data. You're describing your data. The most common, the gender most affected is this. How? Because you have your descriptive statistics. Now, when it comes to dispersion is like saying the spread of data. When we talk about the spread of data, it's how far is the data spread from the mean. How far is the data spread from the mean? Spread of data. How far from mean? And what does this mean? What can we measure? We can measure what we call, we can measure interquartile range. Interquartile. There's an R. There's a interquartile range. Or we used to call it the IQR. So all these things, you'll talk about them when you're reporting, or you should talk about them when reporting your data, depending on whatever you've collected. So what kind of interquartile range are there? We have for example, we have the first interquartile. We have which is usually the 25th percentile. We have the second interquartile range. And then we have the third interquartile range. And our third interquartile range, we call it the 75th percentile. So you're able to calculate this interquartile range. So how can we demonstrate the interquartile range? The data, again, you sort the data from from the way we've sorted it there, 5, 6, 6.5 etc. You sort the data. Then for quartiles, you divide it into 4. So here is our data. 5, let me copy here this data. which I added an extra digit just to demonstrate. So I have my data here. I paste it. That is my data. Let me space it a bit so that you can see. 1, 2, 3, 4, 5, 6, 7. So we divide it into quarters, into 4 parts. So I can divide it into 5 and 5, here 6 and 5, 7 and 8. So it means our data is not, it's not even, but we'll still divide it into, first into 100, that is percentiles, and then from percentiles into quartiles, into 4 equal parts. And then from those 4 equal parts, I then calculate the 25th data point, the 50th data point, and the 30th, not the 30th, the 75th quartile range. Are we together? And then to get the range, the interquartile range, I need to subtract my third quartile range from my first quartile range, meaning I'm subtracting my 75th quartile range from my 25th quartile range. So my first quartile range, okay, my first quartile range is actually my 25th percentile. Okay, this is my 25th percentile. My second interquartile range is my 50th percentile, and my third quartile range is my 75th percentile. Are we together? So to get my interquartile range, I will take my third interquartile range less my first interquartile range. Okay, so what am I doing? I am calculating the spread of my data from the mean, Okay, so all these are 5, 5, 6, whatever. These are my data. I've sorted them from the first to the last. Then you get the median. Yeah, you get the median. So what is my median here? Class, what is my median between in this my data? What is my median?
It is 6.5.
Yeah, it is 6.5. Then half of the 6.5. So here, my median is 6.5. So what is half of the 6.5? Half of it is what?
3.25.
Yeah, 3.25. 3.25. So half of my median is 3.25. So the 6.5 is my median. So I've divided my data into 4. Then my half of it is, then I can now subtract my Q3, which is my my third quartile, from my first quartile. And that's how I get my interquartile range. So it is the spread of the median half of the data. So when you're calculating the interquartile range, it is the spread of the middle half. Of data. That is my interquartile range. So when we talk about dispersion, the first thing we talk about is interquartile range. The next thing we talk about, so I'm sure you've done this before. I cannot believe you did not do this. So the next thing we talk about is, wait, I need this to be small, is my range. So what is my range? My range just means 10 minus 5. My range is 5. What does range mean? It is the difference between between the highest value, here in our case, highest value, and the lowest value. what is my range? Maximum value, lowest value, my range. When we talk about dispersion, we then talk about standard deviation. I think the best thing is next class, we have a set of data, actual data, and then we're able to see how to calculate it. So what is the standard deviation? Actually, the standard deviation is actually the most common measure of spread it is actually the most common measure of spread. This one is the most common measure of spread. It is the most common measure of spread. And what exactly is standard deviation? It is the measure of how far your data will deviate from the mean value. So here we're asking the question, let me just squeeze it here. How far will your data be, or how far will your data deviate from the mean value? So let me start a new PowerPoint. Let me divide this, a new slide. Let me remove my measures of dispersion. And I put my measures of dispersion here. Then, if you go and check your notes, you will see you have actually done this before. Let me remove this. Let me now introduce equations that I don't think you need, but let us see how things work. So, give me 1 minute, I get you proper diagrams from somewhere. So I can't find my notes. 1 second. Here, can you see my diagram? Interquartile range. You arrange your data in order. Here are your points. You have your minimum and your maximum data. In our case, 5 and 10. You look for the median. Then you divide the median into half. Then you're able to get your quartile range. First quartile, second quartile, third quartile. The range, interquartile range means you take your Q3, which is your 75th percentile, minus your Q1, which is your 25th percentile. I hope we're together. Let us look for. Are we together? Are you able to see my PowerPoint? I cannot tell when I'm on so many screens. No, it did not come. Why? It came. You're able to see my diagram? Yes or no?
There's no diagram.
And now?
There's a diagram.
Yes.
Yeah. And this is how you will understand your interquartile range. You put your data in order. You divide it into 4. Yes, that means you get your half of your median. Then you can see your Q1, Q2, Q3. The range, Q3 minus Q1. Okay. Then we look for range. What is our range? Our range is just our highest minus our lowest. Okay. That simple. Here is our range. Paste. In our situation, our highest was 10. Then our lowest was 5. So your range is just the highest plus the lowest. Okay. Then we have our standard deviation. Okay. Standard deviation. What is the standard deviation? I'm very sure you've done this before. In fact, how far it deviates from the mean. So how do we calculate our standard deviation and even our variance? I'll put next so that you're able to see. I want to copy this image. Here's a standard deviation. Even from 4, we used to do the standard deviation. Okay. Our standard deviation is calculated like this. So our x is the number. Yeah. No, our x is, yes, the number is our mean. X is our mean. And we want to see how far you're deviating from the mean. Okay. So the square root of standard deviation is what we are calling the variance. Okay. And it is also a measure of dispersion. So our standard deviation is the sum of the mean minus x bar over n minus 1. Okay. Where x is our, we're saying x is our mean. So how far is our data deviating from the mean? So we're saying standard deviation is one of the most common measures of spread. It's how far your data deviates from the mean. Okay, so that is a measure of dispersion, and so is variance. Now variance, let me just write it here so that you can see it. Variance, we used to say, it's just a measure of variability. Variance, let's say variance is just a measure of variability. So in standard deviation, we usually actually call our standard deviation from the population, is how far it's deviating from the mean. But the variance is actually the average squared deviation from the mean. Okay, so a measure of variability, or you can also say it is, how do you put it? The average squared deviation from mean. And that is it. So here is our variance and our standard deviation in this equation. So you can see our x in that example that is there. Those are our values. Xi are our values. X bar is our mean. If you add 17 plus 15 plus 16 plus 18, you put them in order, you're able to get your mean, which is 16. Then you take how far is it deviating from the mean. So the first one, 17, deviates by 1 from the mean. 15 deviates by -1. Then you get that, there we say x minus x bar, and you get those figures. So those are the figures you're going to then square and then do n-1 to get your standard deviation. And then from there, you then find your variance, yeah, the measure of variability. So that is how we get our variance, okay? So, and by the way, variance, just for information, we usually have two types of variance, sample variance and population variance. That one you look at it another day. I don't know how far, I don't think, this is not a statistics class, okay, it is not. Now we have shape of data. Shape of data. But since you're university, let me just point out that we can have population variance and sample variance. Now, shape of data. What is this shape of data? It describes the type of graph. It's just the type of graph. So you present your data. Remember we said statistics, how you also present your data. Why is the shape important? Because you can make a decision about the probability of data. Yeah. And the shape can either be, let me see, the shape can either be, it can be what? It can be symmetrical. Let's look for a diagram before we have to open many PowerPoints. So let me look for shape of data. So I'm just going to just put an image so that we have an idea here. When you draw your graph, when you have your results, you can have this kind of shape. I hope you can see. I'm putting diagrams. I cannot tell whether you can see or not. Shape of data. And incidentally here, this diagram shows you the mean, mode, and median as well. Okay. So if your data can either be positively skewed, it is on the left. It can be symmetrical or bell-shaped. It can be negatively skewed. That means from the mean, it is going to the left. So shape of data. So in symmetrical data, as you can see in symmetrical data, the mean, mode, and median are close together. Can you see? In the middle one, symmetrical data, mean, mode, and median are the same. They're together. If it is skewed to the left, as you can see, the mean, mode, and median are dispersed in this order. The mean, you can see the median and the mode. If it is skewed to the right, it forms now a different type of curve, where again you see the mode, the position of the mode, the median, and the mean, yeah, is on the left. Hope you can see the difference. So symmetry. Spell this correctly. Type of data, it can be symmetric data, okay? And I've showed you. But what else can we talk about in the shape of data? We can talk about what we call skew. This should be B. Is it B? A was that, so this one should be B. You say that be it's the skew. What do you call it? Skew. I don't know what happened to my notes. So they should, but this should be correct. So skewness of data. I talk about the skewness of data. What is the skew of data? It's a measure of asymmetry. Just a measure of asymmetry. Asymmetry in the data distribution. Measure of asymmetry. So if it's not symmetrical, as you've said, it can be skewed either left or it can be skewed to the right. In which case we can say that data can be positively skewed, can be positively skewed, or it can be negatively skewed. So when you're describing your data, you can state all these things. The data was negatively skewed, or my mode was this, and all those kind of things as you tell us whatever you investigated. Okay, positively skewed, negatively skewed. Where is positively skewed? The first one. Where is negatively skewed? The second one. So all this time you're describing your data. So you see, this is descriptive statistics. So negatively skewed data, we have seen it's to the right. Here it is skewed where right. You have your values going to the right. Positively skewed data, it is skewed to the left. And left, why? You can see the mean and the median will always be greater than the mode. The mean and the median, the mean, the mean and the median is always greater than the mode in positively skewed data. In negatively skewed data, the mean and the mode will always be less than the mode. That is what we are calling skewedness when you're describing your data. Something else you can describe descriptive data as a measure of dispersion is what we...
Madam,
So yes?
we are supposed to have another class.
Okay, but you go and look at these notes, you've done them before. Will you look at them? But the last, let me just tell you, the last measure of dispersion is kurtosis. So just go and look what this kurtosis is. We used to say it is, what did we used to say? It is plating. I never teach these things because it should be covered in another topic, but just listen. It should be kurtotic, it should be, it can be meso, kurtic. That's why it was saying kurtosis. Can measure kurtic. Am I spelling it kurtic? Or it can also be leptokurtic. Leptokurtic. Okay, so because I'll never say it again, can I put the diagram? Then you go and think about it.
Yes.
Let me put it. Kurtosis in statistics. Kurtosis, I've spelled it wrong. Kurtosis in statistics. You go and look at this diagram. So these are all descriptive statistics. Can you remember them when we say them? Or you've never heard of these things? So if it is platy, it means plate, it's flat. Your measure, your data can be platic, it's flat. The tails are flat. As you can see, this lower graph flat. If it is Mesocortic, you see, it is normal. The data is widely distributed. If it is leptocortic, data is very thin. It is distributed very closely together. The height is high. There are types of. So when you draw your graphs, you'll be able to tell these types of measures of central dispersion. And I think we've covered everything. The shape, and we covered the shape, the dispersion. So those are the measures of dispersion. So you go and read about the other measures. My cat must be next week. Have a good day. So refresh your memory. I know you've done this before. Even you've wasted my time repeating. But revision is never a bad thing. So have a good day.